Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials or any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com. Thank you.
Okay guys, so let's get started. So what we did last 2 days, we discussed about what is Kubernetes, why Kubernetes, how Kubernetes works. We installed the Kubernetes. We worked with setting up the clusters, setting up the workstation, setting up the worker, setting up the master. Then we worked with the various APIs, which includes namespace, pod, replication controller deployments, and many more. Today, now we are going to spend good amount of time on the services, which is the most important one. Okay, so before getting into that, do you have any questions, any doubts? Anyone has any questions, any doubts? No. So let's get started. So now I'm going to talk about services. Now the question is, what is services? So see guys, we discuss about everything. We discuss about the master who's managing the cluster. We discussed about the worker who's doing the worker like creating a pods and all, managing the pods. We discuss about the workstation also who instructing the master to doing the desire. So once you run the pod inside a worker, okay, how can we access it? How can we access from outside? I think someone had asked these questions yesterday. How can we access it? Okay, and today through the service topic, which we're going to talk about the same thing. So look at this image here. Here you have a six node, six worker, and each worker you have pods. Some nodes have a more pods also. If you see that each pod you have IP address. If you again see it carefully, uh, then you see here the each pod has a container. Again, if you see, some pod has a front end container and some pod has a database container. Okay, so different containers are there, front end, database, and stuff like that. Okay, okay. If you see that node 5 the pod dies because of some reason. A new pod get replaced with a new IP address. Same pod got replaced, but a new same pod got replaced. I mean, new pod you got it, same image, same container, but you got a new IP address. So this is the scenarios which you have in a cluster. Okay. So now the question is, in this picture, the question is, which front end will talk to which back end, which database? So if you see that how many database we have, database we have three, db three, db1 three containers, three pod, and front end we have a four containers. So now the situation is like this: which front end will talk to which back end? That is the situation right now. Okay, So now the front end will talk to the pod with the IP address which is 91, or pod with the IP address which is 44. Okay, so there's a confusion. So if you have this kind of issues because you run multiple machines in the front end, multiple machines in the back end, in the real time scenarios, how do you solve this problem? In the real time, how do you solve this problem? Anyone? Hello? Hello? Guys, can you hear me?
Yeah, we can hear you.
So how do you solve the problem in real time? If you have a certain problems, let's say you have a 4 front-end virtual machines, VMs, and 2 back-end database. So how do you solve the problem? Which front-end will talk to which back-end? How do you solve it?
Maybe like service version something. Not sure.
I know I know that you guys know. I know that you guys know. It's just a matter of recalling those stuff. Anyone has any guesses? How do you solve this problem?
Something like VIP, they will assign for one IP for all the common services.
Something else? Something else, guys? Have you heard about the concept of load balancer? Have you heard about this? Yes or no?
Yep.
Yes. Yes.
So, do you think load balancer will solve this problem?
But
Yes.
load balancer will route to the request, right?
Ha.
I mean, available front end, it will route to the request.
Okay. So I think we need a little bit discussion here. See what happens. Route balance, route the request. So see here, I have multiple front end. So look at this here, this image. I have a multiple front end running as a web server or app server, whatever it is. And now I have a multiple backend. So, and here, this is the end user. Very simple architecture. So now this guy confused, he will connect to which one? So for that, there'll be one load balancer set it up for all of which. So this guy will hit the load balancer, typically DNS server, but right now load balancer, and load balancer decide one of selections. Let's say this one. Let's change the things. Now load this application has a problem. They will hit which one? So here we'll create one more load balancer, but this time load balancing all this port. Okay, so now application will hit this one, and here this guy said go to this place. So did you understand this?
Yes.
Don't you think so? This is a solution. We use it every time. So here, what do you think? Can we bring the load balancer here? Can we bring the load balancer? See here, there's one more problem here. New pod came because of new deployment. You got the one older pod and two new pod. You got it. IP address got changed. Now the how the new pod will be. So now the second problem is the front end will go to the V1 or V2. There's more confusion actually. Solution is service. So what is service? That's the question. So guys, did you understand the load balancer requirement in the earlier MS Paint?
Yes.
Yes.
So guys, in short, service is load balancer. Yes, service is load balancer. Okay, what is service? Load balancer. Free of cost load balancer. Free of cost load balancer. Okay, so now we will come to know
Yeah,
what is
Rajesh, I have
service
one
indeed.
doubt here.
Yeah.
Like whatever the DBs we do have on the port number 91 as well as the one more port. What is that? Okay.
44.
44. Both versions are V1 and V1, right? If any particular one service, like for example, the front end request got modified the pod 91, then the same change has to go for the 44 as well, right?
Yes, same changes I will have to go for 44. That's true.
So for that, what we should do, like for example, syncing the data between the parts.
Syncing the data between the pods means
Like for example, something happened to the pod 91, the same change needs to be done for the 44 as well, right?
that's true. Yeah,
90. Okay.
that's called
Yeah.
rollout process. Remember rollout we did yesterday.
Oh yeah, correct. Yeah. Okay.
Rollout we did, right? We changed the image and it created a new version of it, and then we did rollout, rollback, both we did it, and through status command we monitor also, and then how this upgrade has happened. Remember that rollout strategy, the one which I discussed.
Yeah.
So yeah, that we will do that. So we have crossed that phase now. Now we are talking about, okay, we run the pod, that's okay, but how do you access it? That's a question. So here service is the one. So guys, what is service? Service is a one of the load balancer, one of the kind of load balancer managed by Kubernetes cluster. Managed by, it's a managed service. You don't have to worry about it how it works, but it works. Okay, so it's inbuilt properties which has a capability of the load balancing. Yes, service is one of the API object which has a property of the load balancing. So service IP address never change. Again, understand that here. Pod come and go. Pod's IP address will change if you get a new pod, but service IP address and DNS name never get changed. Service IP address and DNS name never get changed. So yes, service will help you to load balance the database pod and all the application. You can say front end application, you can say go to the service. Now service will decide whether the traffic should be redirected to the pod 91 or pod 44. Okay, so now did you understand that how these services will play important role in terms of load balancing the pod? Did you understand? Here we needed two service, one for database, one for the front end also. Make sense, guys?
Yeah, Rajesh. Rajesh, I have one question. I
Yeah.
think it's about what just now Obul asked. Consider like we have two pods, one is front end, two pods. So
Mhm.
with the one pod, I'm sending one request, uh, like saving one employee detail, and it will come
Mhm.
to service, and service will decide which DB pod has to be uh, talk. For example,
Mhm.
it stored in the IP address 44.
Yeah.
Okay. And the next time with another front end pod, what is that 83? So it's looking to get that information. So next it will come to the service. So instead of it's talking with the IP address 44, the pod, if we talk with the 9, so do we get the data?
Ha. I must
Radhakrishna,
tell you,
actually,
this
I
is
can
the
answer this. This is
Okay.
regarding the database. So
Uh-huh.
each of the database has its own configuration, how you can keep the pods in sync with each other. So you will have to see which database you are using. For example, Postgres has its own metadata that you have to provide in the while creating the pod. How do you sync it with another pod? So it is database dependent.
yeah.
Okay.
That is one. That is the one thing. But let me give you one more answer. Okay. That's also one you can. The one which he's saying that we is called stateful set. Okay. So I'll discuss about that scenarios also. But one simple scenario I will give it to you here. What is happening in the database also there is a clustering concept actually. Clustering concept. See here. MySQL clustering. See, it's not like we've been always thinking database is the one copy. No, like etcd with the see, we can set up a cluster. Now, in a simple way, image is a best place to get the idea. See here. So this is also clustering here. So in short, I will tell you here clustering like a data node 1, data node 2, node SQL and master node. So lots of concept is here also. But let me just put it in a simple way. What happens? Database, when you look at the database architecture, typically they have divided into two parts. Okay, this is your database server, and this is typically divided in two parts. One is like an engine, okay, database engine, and second one is a database directory, data directory. Now, engine is an application and this is a static file. Okay, these are the file which dynamic which changes. This file is get changed. This is the application which not need to change, only this get changed. So who changing this through DDL and DDL and DML? The engine is changing here. Okay, so yep, in a simple clustering, what you have, this engine I am talking about. So now let's create this one. So here when I say it's an engine, database engine, there's a database engine, database engine, database engine, and then here you have a database directory. Okay, and here all this is making the changes. Okay, so when I say the creating a load balancer, then you are creating of the application. That's one of them. Let me tell you, there's a 10 things, 10 ways are available to set up a cluster. I'm not talking about that. I'm not talking about the Kubernetes alone. It's just a generic configuration. Did you understand this? Okay.
Yeah. Raj.
Hello.
Yeah,
Now,
I
one more
understand.
thing here. Yeah, you can create a cluster of data directory. You can create a cluster. Every tools like every RDBMS and MongoDB also allows the clustering. Like you can have a multiple data directory and they will sync each other. That means let's say it get updated here, no, it get automatically sync here. Not you are doing. Cluster of the MySQL or Oracle or MS SQL will do that. So you can set up a clustering also like this. You see here. Look at this, probably this image. Look at this here. So here request come to the MySQL router, okay, and then he updating the, see, look at this. This is a good image actually. So here, this there in the AWS also. See who's a read and writing one, and which is a read and which is a read. So for reading, you can use the DB2 and DB3. For read and writing, you can use the DB1, whereas the DB1 is syncing with the DB2 and DB2 is syncing the DB3. So group replication is there. So those can be set it up easily. I mean, once you are a database expert, you can set it up in the production server. But in our laptop, when we install, typically we install one database server which includes all the components in one go. So that way it's very difficult. So now you are getting when I say database sort of concept, then it's a clustering.
Yeah, I think
It can be, but
yeah, it's the DB architecture itself like that. So that service provider will take care of that, right? The MySQL or
right,
MongoDB, they will take care of that. Thank you.
correct. Okay, so service is the one which is a load balancer. Okay, now the new pod, the question is you should be having in your mind, okay, fine, I'll create a load balancer balancing few pods which is existing, but this new pods keep coming actually, and the old pods keep deleting because you have experienced already deployment. So you know that now what is how this new pods is keep coming and old pods getting deployed. So this will keep coming. So how this service will automatically update, that's a question. See here in this scenario, two new pod you got it, two new IP address. So how this two new pod will register with the service, that's a question. How? So how can it be registered? One more scenario here, look at this. So you have one deployment of V1 with a 2 pod earlier. Then you did the V2 deployment with 1.2 images, but you got a replication to 2 to 4. So you have a old two image also and a new 2 images also. So there is a problem here. There is a problem here, like in your deployment, you have a 2 old image and 2 new images. Okay, you deploy this 2 old image, 2 new images. So what do we do in this case? Now the service should go to the V1 or V2 or V1 V2. So this is not good combination. Look at this here. Sometime what happens, if you log into Gmail, you see now you see 50 emails, okay, and suddenly after 5 minutes if you log in, you see 25 emails. This is not expected results, right? This is not desired. No one will accept this. So this is the kind of thing. So how this service will only should redirect to V1 and V1 or 1.2 or 1.2. So how can you do that? So look at this problem here. New pods come, how the new pods will get automatically registered at the service. How can we, when we upgrade the deployments, how this service should only redirect to the new pod, not a new old pod, so that way the user will get a consistent results. How can we do that? That's question is how, and that's where label rocks. Someone asked this question, what is a label and all. That's where I said labels will do the things in the service, which we'll talk about it. So label rocks. So we have done it, this some of the labeling and all, we have done it through YAML file, though you can do labeling through command line also. There's a one command which is called kubectl label. You can do the labeling. Guys, let me tell you here very simple thing. Labels you can apply to any API resources, any API resources. Okay, label is been applied for various purpose, uh, various purpose. Sometimes filtering, sometimes for affinity, sometimes for tenting, sometimes for selector, sometimes for searching, sometimes for service. So label works. So labels with the pod is good for the services. So how label works in the services, I'm going to talk about. Look at this very carefully. Okay, so here you have a service, here you have a service. Okay, here we have service and labeled with the prod b 1.3. You have a 3 pod labeled with the prod b 1.3. So what rules suggest, please hear me out. If the labels of the pod, if the labels of the pod is matching with the labels of service, automatically pod will get load balanced by service. If the label of the pod is matching with the service, Again, I'm repeating, if the labels of the pod is matching with the service, automatically pod will get load balanced by the service. And there is a one to this statement, I am putting the one string asterisk. Why? Because this statement is wrong, but not entirely wrong. So you must be wondering why I'm saying wrong statement. There is a reason for it. I want you to understand the concept first, and while doing it, I'll correct the statement. Little bit minor modifications needed. That's all. So the how this pod will load balance, the how the service will load balance the pod, simple. Match the label. Match the label, load balancing will happen. Okay. So if you match the label, there is a one more component. You might have seen that component, and then component is DNS, core DNS. Have you seen this pod, core DNS? Any one of you? Have you seen this core DNS in your cluster?
Yes.
Yeah. So what happens whenever you match the labels? Whenever the core DNS find out this, the core DNS is discovery service. Okay, DNS for the cluster. So core DNS, whenever they found the pod which with the label is matching, service, they update the service with their pod IP address. That is what has been done. So here pod labels matching with the service, automatically load balancing happening. Let me tell you with that rule, whether this user did the right labeling or not in this image. Tell me whether user did the right labeling or not. Tell me whether user did a right labeling or not. Anyone? Hello?
Yeah, might be add one more label here, because even service is also having the the the, the three labels.
Anyone else observation?
Label has two parts, right? Key and value. So what this signifies here?
Okay, yeah. That's okay. The label has a two part, key and value. But right now I don't want you to read that. That's correct. Okay. Consider the labeling is done, and the plot is a key and value together.
Okay.
So I'm asking you to look at this. I'm asking you to look at this, whether this labeling is done by the engineers correctly or not.
Okay.
Because I said one statement, if the label of the pod is matching with the label of service, automatically the pod will get load balanced by service. Why? Because with the help of the core DNS, core discovery services. But whether labeling is done correctly or not.
I don't see any sense with BE. So prod under 1.3 is fine, but I'm not sure what is the label called BE.
B label, no, that's okay. B means backend, something like that. B, that's a different. How many labels you can give? N number of labels you can give. Concept is saying if the labels of the pod is matching with the label of service, load balance will happen. But my question is it the right labeling or not?
Here, all the labels are look same. So I think he didn't provide the right one. So it means when it load balance, it will not sure where it will route.
No, but it will route. No, I said very clearly, if the labels of the pod matches with the labels of service, please hear me out. If the labels of the pod matches with the label of service, automatically load balancing by the service will happen automatically. But that's not a question. The question is whether it's a right labeling or not. That's what I'm asking.
To get our channel membership, click onto the join button, select the 399 plan and grow your skills immensely.
Look at this.
For
Understand?
the other pod, I think for the auth pod, the labeling should be different because it's a different service, right? I mean, it is different.
Correct. Yeah. So sometimes see that here, what is a mistake here? DB pod prod B1.3, DB pod prod B1.3. But why did you label auth with the same label prod B1.3? So what will happen here? The auth pod is matching with the service label. Then service sometime will redirect to auth, sometime to DB. So it's not good, right? Service should redirect to the similar pod, right? Not the different pod. It's like this. Sometime I click on the I logged into your service, and then sometime I go to the dashboard, and sometime I go to the registration page. Will you accept this behavior? No. Are you understanding? Are you getting what I'm trying to say?
Yeah, now we got it.
Yeah. So now the question is, who is doing this labeling? Pod labeling, service labeling. Who's doing it? You and me will do that. We, all of us are doing. Engineers will do that. So whose mistake is? This is our mistake. So this is the one work which you have in Kubernetes, because Kubernetes will do everything. But whenever you create any object like a pod and services, make sure that you have a right labels, because if you have not right labels, then you know the disaster will happen. So this is our work. We did the mistake. So one of the our responsibility in Kubernetes is to not only write the deployment which create a pod and service, but also we have to label it the service matching with the deployment to make sure that the service will load balance the right pod. It should be load balancing the similar pod. Okay, so this is our responsibility. So please understand that. Okay, so now here you see what has happened. You modify the service labels, you deleted one. The moment you deleted one, now it is load balancing 4 pod. You see, labels of the pod labels of the pod is matching with the labels of the service. Now here prod B, prod B, prod B, prod B. Forget about 1.3, 1.4, 1.3, 1.4 and all. So now this service is load balancing 4 pod and a different version. So can you tell me what is the solution here, guys? What is the solution here? It is a good labeling or not? Again, same question. Is it a good labeling or not? And this time, one more question, guys. How to correct it?
With the version in
This
the
is
service?
bad because we have to have same versions. I mean, if we are upgrading one, like we have to upgrade in every DB.
Right. So how do we correct this? So I should get either only 1.4, not 1.3. So how should I correct it? Service should load balance only the pod with the 1.4, not with the 1.3. So how do we correct it?
With version label in the service?
Yeah, correct. We have to add 1.4 to the service, and look at this here. Now it's load balancing the right pod. 1.3 we need to clean it up later through the n number of ways. Okay, so guys, this is a service. What is service? So guys, service only send the traffic to the healthy pod. Yes, service only send the traffic to the healthy pod. It can be configured with a session affinity. It can point to the things outside of the cluster. Yeah, service is accessible inside a cluster, but it can point the things to outside of the cluster also. The algorithm which it applies in the service is the random, understand that, random load balancing. Okay, and it uses TCP by default, IP address by default. Make sense, guys? This is a service. Have you understood this?
Yes.
All of you?
Yes.
Yes.
Okay, so this is a service, and now I'm going to create it with your help. First time I'll create a manual base, you'll understand. Then I'll show you the magical command. Within a one command, you'll do everything. So this is a service. Deployments we have discussed already. So I'll just move on. That's all. Okay. So guys, can we go into the demo now? Any doubts? What is about the service? Okay. So let me log into the cluster. This is the worker 1, this is the worker 2, this is the master. Start. Okay. So guys, let me explain you few more things along with it, which is important. So today is the day 3. Okay. So guys, service basically you have types. Yes, types. Service have a types. Okay. Now the question is, which are the types? So it has a type which is called node port. Understand that, very important topic guys, very important. Node port. And one more thing, I spent myself only when I started Kubernetes long ago. I had a very bad time struggling this concept. Node port, service, basically service types, node port, and the first one is clustered IP, and load balancer, and external name. Out of which first 3 I'll talk about it. 4th one I'll let you discover yourself. Now I had a very bad time. It was very difficult to understand at the time because of very less documentation at the time it was available. Okay, so now you have a very rich documentation, but let's close this topic for forever in this session only. So after this you should not be having any question about the service, clustered IP, node port, load balancer. So what is the clustered IP? So let's understand this. So this is a cluster. And in this cluster you have a only two worker right now because for the image limitation. Now each node you have IP address. Okay, and this is the area of the cluster. Okay, now this is me somewhere outside, end user of that pod. Okay, outside. Now can I access this IP address? Can I access? I mean, if that firewall allows, can I access?
Yes, you can.
Yeah, because I'm accessing the IP address, public IP address, you can access. If firewall is allowed, you can access. So this is done. Now the pod is here. One pod, two pod. This is the application pod. Okay, this is the application pod, and this is the database pod. Database pod. Now guys, pod also has IP address. This IP address, this IP address, this IP address, this IP address. Now can I access this pod IP address?
Yes.
Even though firewall is allowed?
Yeah.
Pod IP address. Think pod IP address.
No.
Pod no.
First, we need
Pod
to go
no. Why?
node IP, then you have to access the.
Right, yes. Something similar we have done in the Docker alone also. Do you remember that option? I forgot. What was the option in Docker to access the container? What option we did? We used to use it, no, that option. Anyone remember? In Docker, what option we did to access the container from outside of the node?
EXEC-IT.
No, IT for interactive, no? Something else.
Curl command you're talking about.
No. There was one option we used to give it. So container will be accessible from outside of the host. Container by default it was accessible within a host, right? But if you want to access from outside, we used to apply some more options. I'm asking that one.
Attach the.
No, attach for the attaching becoming, no. I will not get access from outside of the container over the HTTP.
Port
mapping,
forwarding.
is it?
Generally, we do port
What
mappings.
Port
what
forward.
options were there? That is, what were the option? Anyone remember? -P, guys, you forgot, I guess. -P, correct, no? Do you remember -P option?
Yes.
Okay. Yeah, same option I'm talking about. So using -P, what you used to do? You see, simple concept. First learn with the container, then we'll talk about it. So see here, this is the node. Okay, this is the node, and this is a Docker 0. Docker 0 is what? Is a bridge, and this is the container. Container get IP address. I'm outside. Can I access outside? No. Can I access the node? Yes. So what we'll do here, we'll create a port forwarding. So whenever you hit to the node port, it will go and redirect to the proxy to the container IP address. So this is called port forwarding, port proxy, or something like that. How can we do that? -P option was there in a Docker to do this port forwarding. Some of you might have tried it out to access the container from outside. Container is accessible inside with this IP address, but not from outside. So something similar, not exactly, but something similar we are doing here also. So now, can I access the pod? No. So guys, here we have a proxy. Each node you have a proxy, right? Do you remember? Each node you have a proxy. Now proxy assign this IP address, remember? And each node you have a ETH0 also. ETH0, understand that, right? Each one of you. ETH0 one network to the each node, right? Okay. So now what happens within a cluster I'm talking about? You know that networking rule. So any pod within the cluster can communicate with any other pod. So Hello. Hello, guys. Can you hear me?
Yeah, I can hear
Yeah.
you.
Yeah, we can.
Okay, because I thought I got disconnected with the internet. Okay, so here networking rule which states any pod can communicate with any pod. This pod can talk to this pod, this pod. That's a networking rule because of the Q proxy. Okay, that's a because of Q proxy. So here what is happening? Pods can talk to each other in the within a cluster. So outside of the cluster, I will not think about it. So right now, what is the situation? This is the application. This is the database. Think about it. So what we need here in between one, we need a service. Correct now? So application pod and database pod both are in the same network. Both are in the same network. So here they can communicate with the pod network. Remember pod network you applied ViewNet or something like that. Do you remember?
Yes.
Yes.
Yeah. So all is in the same network. You can apply over the Calico also. Just say one YAML. You can apply Flannel also. One YAML is there for each one of this networking. So here they can. We need a service which can load balance the over the pod network. So now we need a service which will load balance the database, and application will hit the database here, sorry, service, and it will redirect to the one of the database. So this service which I create to load balance, understand that very simple concept. This service which I create to load balance the pod on the pod network, that service is called a cluster IP. So that means service will get this service will get a cluster IP. Cluster IP means pod IP, pod network IP. So here what I am going to do is I am going to create one service. Now service inside a cluster, understand that. Service inside a cluster and service inside a cluster, and this service will load balance database pod 1 and 2. So now what happens? Applications can access this one and this one, and this service will decide whether it should travel to database 1 or database 2. Did you understand this concept?
Even though in the same pod, right? So sorry, in the same node, correct?
This service, this service you're talking about?
No. Application and database are in the same pod. We talk about that interconnectivity. So each pod can access, interconnect, right? So and between pods also can able to access different nodes also, correct?
Yeah, that's a networking requirement. That's anyways possible, no? With the help of the Q proxy, remember any pod can communicate with any pod directly within across the node also. Yeah, in a cluster, but not outside of the cluster. Now, who's making it a possible? Proxy.
Proxy. Yeah. So what we are saying is like, so in order to connect, even though within the same node, two like applications and databases are there, but in order to access the database, that application has to go to the services and DB services and access the database, right?
Yeah. Within a node also, you have to go to the service because that is a load balancing, correct?
Yeah.
The service will decide which pod you should go. You cannot decide in that case because you have multiple pod.
Yeah.
Okay, so now did you understand, guys? So this service is basically called a clustered IP because this service will get the IP from the cluster only. Okay, this service will get IP from the cluster only. So guys, did you understand this service type?
Yes.
Guys, now there is a problem, guys. So I need to create one more service, no, in that way, that logic. So I have to create one more service for what? You know that. For what?
application.
For application.
Yeah. So I have to create one more service. So this time application, this service is load balancing applications. Okay. Now this service is load balancing application, and application is used by end user. So why is the problem here is this service I need to access, but the problem here is this service is on what? Cluster IP. This service also on a cluster IP. So can I access? No, I cannot access. I cannot access this service. Why? Because it's on a cluster IP, pod network, Kubernetes network. So it's a different network. So how can I access? So guys, when you have a two network, understand that. Then we do the routing. We do the routing. Okay, routing or port forwarding, whatever you call it, proxy, all these things. Routing, we do that. So this is something you do between the two network. Okay, two network. You do the in the home also, right? See here, internet come from the outside, router convert into your private network and transfer that to your private network, and then within your home all of your laptop can talk to each other but not outside. So routing. So what need to be done is I cannot connect to this service, that's true, but can I connect to the node if firewall is allowed? Can I connect to the node? Yes. Why? Because pod is on the physical network. Sorry, node is on the physical network. Think, node is on the physical network, whereas service is on the pod network. Pod network is accessible. Scope of the pod network is accessible within a cluster only. But the node network, which is the node network, I can access if the firewall is allowing. Don't you think so? Don't you think so? Guys?
Rajesh, here is the confusion is like cluster have the nodes, right? Node have pod.
Yes, cluster.
If we are not able to connect to the cluster network, then we cannot access the node as well, right?
I will probably think about it. Okay, I got the applications up and running. This is my cluster IP address. Okay, this is my IP address. Can I ping? Look at this. See here. Can I ping from my host machine? See, I can ping, but can I ping the pod network? Let's do one thing. Let me help you to visualize this. Where's the putty? Here it is. I'll get one pod which you guys are running. Let me log in to this. kubectl get pod -o wide. See, this is the pod.
Hello.
Yeah, Rajesh, we can hear you. Yeah.
Hello. Hello.
Yeah, hello. We can hear you.
Okay. Yeah, I think my home network, home internet has gone, so I'm connecting to the data network. So I hope you are able to see. So can you hit the IP address of container? Sorry, IP address of node. Can you see my? Hello.
Yes, we can see.
Yeah.
Hello?
Yeah, we can hear you.
Yeah, yeah. So see the IP address of node, but can I ping the IP address of pod? See here. I'm outside. Can I ping the network? Yes, that's fine. Hello. Hello. Yeah, it's not sure.
No, hear you
Yeah,
clearly.
there is some disturbance in your
We
line.
can hear you.
Oh, yeah, because I love the home internet. So I'm connected to the data network, so it's getting only 10 Mbps.
Yes, some
I
noise is
hope it
coming.
should be okay for you. If you can hear me, so what you are seeing right now, which screen?
Created speed screen.
That's good. So guys, did you understand the confusion? Can I connect to the service IP address? No. Can we connect to the host IP address, worker IP address? Yes. So someone has asked this question, I guess. Is that okay?
Yes.
Yes, Rajesh. Got it. Yeah.
Yeah. So now the question is this. Think about it. I can access node IP address. I cannot access service IP address. Why? Service is on the pod network. Node IP address is on the node network. Both are different networks. So what we do in this case? In this case, what has to be done is we have to create one routing. We have to create route that. We have to create a proxy. So whenever someone hit, understand that. Whenever someone hits to the node network, to redirect this service at certain port. Same thing we do in the container also. Whenever you hit to this IP address, then you should redirect to this service. So see that how we are traveling. Look at it. I hit 80 port on the node network. Node network redirected to the service port. Why? Because this node network, if 0, where it's 0 and proxy is on same place, so they know each other very well. Okay, so they redirected to the service. Service said go here or here, and service application will redirect this request to the this service. Database service. Database service can go here. So this is the full communication. This is the full communication. Did you understand that now?
And Rajesh, there is a lot of noise in the channel actually. We cannot hear you properly.
So internet seems to be good.
Maybe can you reconnect if possible?
Okay, so let me share one more time. Because what will happen if I reconnect that, disable my VPN also. So what do you think? Is it good? Okay, I'll just do the quick test. That way I will know that if there is a problem from this side. So I'm typing 1, 2, 3, 4, 5, 6, 7, 8, 9. What do you think? Is it good?
Please enroll our general membership for $3.99 plan to get access of all the parts.
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the 3D99 plan, and grow your skills immensely. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.